Good evening, students. I'm Suji Elizabeth George, your science tutor. So today we are going to continue the class about atoms and molecules. So in the previous class you learned that various philosophers said that matter is made up of smaller particles called atoms, right? Yes. So let's recap or recall what you have studied in the previous class. Okay, can you tell me which scientist is known as the father of modern chemistry? Yes, it is none other than Antony Lavoisier. Okay, so can you state any two postulates of Dalton's atomic theory? Yes, first postulate says that matter is made of smaller particles called atoms, and atoms are indivisible. Okay, so he had given 6 postulates, and first one is this, and also he said atoms can neither be created nor destroyed. Okay, so those were the 2 postulates and 4 more are remaining. Okay, we also studied about symbols of many elements, important elements in the periodic table. So here the symbol of sodium is written as dash according to IUPAC system based on its Latin name dash. Yes, symbol of sodium based on the Latin name natrium, and so hence its symbol is Na. So tell me, Dalton proposed that atoms can be divided into smaller particles, whether this postulate of Dalton is true or false. It's about the postulate of Dalton. Yes, it is false. What did he say? He said atoms are indivisible, cannot be divided. Okay, next is an assertion reasoning question. Let's see what it is. Okay, Berzelius used the first letter of an element first plus second letter of an element's Latin name for its symbol. He wanted the symbol to be easy and universal to use in a chemical equation. What is the answer? Is he the one who proposed that idea? Yes, of course, you have studied. Dalton has used some weird kind of symbols, but Berzelius suggested that it is better to use. Yes, so both A and R are true, and R is the correct explanation for A. Okay, now tell me my nickname. Do you have a nickname at home? Since my name is smaller, I didn't have any nicknames. But sometimes my mother used to call me Sue. Okay. So can you tell me the nickname used for Mercury? Recall what you have studied yesterday. It is Hg. Okay. What about hydrogen? H. Calcium. It is Ca. So when you look at these, we can see that Mercury is Hg. So obviously it might be a Latin name or a Greek name, and the symbol has come from that Greek name. Mercury is actually a liquid metal, or in older days the scholars or scientists used to say that it was like a water which is a metal, or a metal which is a watery type. Okay, so it is called hydragyrum, and from that word Hg came into being. Hydrogen, the first letter was taken. First letter was written as in a capital letter. Then for calcium, two letters are taken. First and the second letter. First letter was written in capital letter, and the letter following was written in small letters. What about zinc? Zinc is ZN. So IUPSC put forward another rule saying it can also be the first number along with any other number, any other letter coming in its name. Okay. What about the symbol of lead? It is Pb from the word plumber. Gold. Gold is an English word which means yellow, but its symbol comes from the word aurum, which is AU is the symbol of gold. What about silver? Is it SI? No, SI is something else. Can you first tell me what SI is? You have studied 1 to 20 elements in the last class. So SI comes in that. Can tell me that? Yes, of course. Its number is 14. SI is silicon. And what about silver? So silicon has already got his name as Si. So silver was called Hg from the word Argentina. Okay. Now iron, Fe. Copper, Cu. So it might not be easy for you to study all the symbols and names of the elements at one go. We will be hearing it during our classes. We will be repeatedly saying and studying, and then it will be very easy for you to remember the names. So no need to get worried about all these things. So can you, for last name I'm going to give is magnesium. Okay, one more. Argon. Magnesium is Mg and argon is Ar. So these were some of the elements which they are present in the periodic table. We cannot study all 119 elements. These are the important ones, and I have asked you to study 1 to 20, right? Okay. So moving on, we have studied about the symbols, and then we also studied about that all the particles are made up of smaller elements, small tiny particles called atoms, and we have also studied about the structure of the atom. And can you tell me, can we be able to divide atom? Yes, of course, atoms can be. Yes, atoms are divisible. It has got various subatomic particles in it, and important ones are protons, neutrons, and electrons. You may be wondering why I am telling you it again and again, but this is for repeated. If you study it repeatedly, it will be in your mind for a long time, and it will be easy for you to recollect. So protons have got positive charge, protons P positive and neutrons have no charge in it, and both these two are found inside the atom. See, this is the enlarged picture of it inside the nucleus. It is found inside the nucleus, which comes somewhere in the middle. As you can see in the second figure, that somewhere in the middle you can find the nucleus where protons and neutrons are kept. And around it we can see electrons. Electrons have got a negative charge. Electrons are circling around at high speed, and when we look at the electrons using a high powered microscopes, we get this kind of image, or whatever device we use to see atoms, we get this kind of image showing that, or we can assume that since the electrons are moving in high speed, we cannot particularly point out at which position the electrons are there at a particular time. It just keeps on moving. You can see a cloud of electrons, and the electrons will be at some placed at some discrete levels in an orbit where it moves. Okay. So, and atoms are very small, very, very small, smaller than you can imagine, and hence its radius is measured in what meters? Nanometer. And 1 meter is 1 by 10 raised to 9 nanometers, or 1 by that small it is. This means 0.0000, that is 9 zeros and 1. Okay, this goes on. So that was about the structure of an atom. So you studied what an atom is, the postulates about the atom, the names given to the elements, and the elements are made up of, if you cut the elements into smaller pieces, or you can say that the building blocks of elements are atoms. Atoms are very small. It is measured in nanometers, and atoms can be divisible, and it has got subatomic particles in it, and those are protons, electrons and neutrons. Okay, so coming about after that, we will be learning about this. You have seen this figure somewhere, right? Everywhere. Familiar with this table? Yes, you might have seen in your chemistry lab or your staff room or somewhere near your chemistry teacher or inside your book. This is called the periodic table, where the elements are arranged. So all the substance that we found in nature, we are finding in nature, is made up of any of these elements, or these elements in a combined state. If you take hydrogen here, hydrogen is being taken out. If you take hydrogen, okay, in this, hydrogen is given number 1. Okay, and then there is somewhere here something else is written 11101. So number 1 is the atomic number. We will be studying about this number. This side and the right hand side, it is written atomic weight, and obviously H is the symbol of hydrogen, and down there is given the electronic configuration that will be learnt in the next chapter. Okay, so here you can see the elements arranged in some kind of order. So hydrogen comes first, helium second, lithium, beryllium. These are the things that I have asked you to study: boron, calcium, carbon, nitrogen, oxygen, fluorine and neon. Then after neon, we'll come and fill in this side. Starts with, did I say lithium? Yeah. Sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon. Then again, after filling all those things, again it will come over here. potassium and calcium. So this thing is arranged in a periodic way and all. You will be studying about this more in 11th standard. Okay, so you can see that these elements are arranged in some particular manner, and towards the left hand side you can see metals, which are mostly solid state. These are also, in the middle also you can see a lot of metals. Also here you will be finding metals, and towards this side some you will be seeing non-metals, and this is a different group called inert gas. They are gases. These are non-metals. Some of the non-metals are solid in state, liquid in state, or gaseous state. You will be finding it. So these are the ways they are arranged in a periodic table. So you have learned that atoms have names. Each element has got a different name. Element of different atoms atoms of different elements are different from each other. So now we are going to learn about atoms' atomic number and atomic weight. So atomic number is something like an address. So if you say that atomic number is 11, you have to go and check in the periodic table where it is, where its house is. That number 11 is the house name of which one? It's sodium. Okay, so it is something like its identity. It's the unique identity that each element has got, and that is the atomic number. So let's see what, and then there are atomic weight as well. Okay, so atomic weight and atomic number. What is atomic number? Atomic number is the number of protons or electrons present in the atom. It can be number of protons or electrons. Mostly you will say protons because protons will be there always, and electrons, since it is revolving, it can jump off the atom at any time. So atomic number, which is represented by the letter Z or Z, is the number of protons. So if we say the number of protons present is 2, then the atomic number will be 2. Hydrogen has 1 proton, so the atomic number is 1. Oxygen has 8 protons, so the atomic number is 8. Okay. So how will you calculate the number of atomic number? It is not simply atomic number is equal to the number of a proton or a number of an electron in a neutral atom. Okay. So number of protons or number of electrons. Number of electrons only if it is a neutral atom. We'll see what that is. Okay. The periodic table of element organizes atoms based on their atomic number, allowing us to understand the properties and behavior of different elements. Knowing the atomic number and weight of an element, it is crucial for understanding the chemical properties and its interaction with other elements. So this atomic number and atomic mass or atomic weight is very crucial in understanding its chemical properties and interaction with other metals. Okay, moving on. The next identity is its atomic mass. So atomic mass of a single atom. How will you calculate the atomic mass? of an atom is equal to number of protons or weight of protons plus the weight of the neutrons plus electrons. Electrons are so small compared to protons and neutrons, so it is very, but we can say that it is negligible. Okay, it is not considered as such. So number of protons is not the number, it is the mass of how many, whatever, if there are 6 protons, mass of 6 protons, mass of protons present plus mass of neutrons will give the atomic mass of an atom. So mass of an hydrogen atom, by doing certain experiments, it was found that it is 1.63673 into 10 raised to minus 27. Okay, it is not that big. Minus 27 kg or 1.613 into minus 24 grams. It is that small. Okay, and so, and it is very hard. You can't take one atom of hydrogen and do the experiment. It is not at all possible. We have to take some big quantity so that we can held it in our hand. Yeah, for example, if it is about sodium metal, so one atom of sodium metal is so tiny, we can't do any experiment with that. We have to take some amount, like a real gram, so that we can hold it in the hands. So this working with these units of kilograms and grams is impossible. So a new weight, a new unit for weight was found out, and that is called, it is called AMU, that is atomic mass unit. That is the unit used. Nanometers were the unit used for radius of atoms. Similarly, a smaller unit like atomic mass unit were taken. It is a unit of mass which is very small, and we will see how small it is. Okay, and so that small atomic mass unit is taken so that it is easier for the scientists to do experiments with it, because we can't take that minus 0.2, we can't even see what is that. Okay, can't see one atom with our naked eyes, and how will we work with these smaller numbers, right? So a new unit was introduced, and that unit is called atomic mass unit. And what exactly is atomic mass unit? We will be studying now. It is, so consider a carbon atom. There is a carbon 12 atom. 12 means it has got number of protons 12 and number of neutrons also 12. Okay, and number of electrons are also 12. It is a carbon 12 atom. 12 is the atomic number of carbon. If you take this carbon 12 atom, okay, and we are dividing it into 12 parts. 1, 2, 3, 4, 5, 6, 7, 8 is this. 9, oh, sorry. Let me give it 9, 10, 11, 12. Okay. Consider, or just think that these are equal parts, and we are taking a single slice from it, 1/12th portion of this whole carbon atom is taken, and if we are weighing it, and that is taken as 1 AMU. And scientist has found out that this 1 AMU, or the weight of mass of 1/12th the mass of a carbon atom, is equal to the mass of hydrogen, almost equal to the mass of Hydrogen, you know that mass of hydrogen is 1.673 and here is 1.66 10 raised to minus 27 kg, and this is also equal to 1 AMU of hydrogen. So this is something we are taking in relation to. We are taking 1 by 12 the mass of carbon atom as a standard weight, and we are comparing it with hydrogen. So that is equal to hydrogen, or the mass of hydrogen is 1 by 12 the mass of carbon 12 atom. So we can once more I'll say about it. So one at relate if you go to a one more if you have going to explain it once more. So if you are going to a market to buy some vegetables, they will be giving us, you have to weigh. Okay, we'll go and say we need 1 kg of onion. So how will the shopkeeper give us 1 kg? He has a balance. Nowadays there is digital weighing balance, but earlier there is a balance, weighing balance like this. At one this plate they will be keeping metal a metal piece which is 1 kg weight, and then we will compare this weight. So we will be keeping it in a weighing balance. At first this 1 kg balance plate, that thing will be down, and we are filling it with the other side of the plate we are being filling it with the onions. So when that comes equal, this weight will be balanced. Otherwise it will show towards, it will be bending or slanting towards the other side. Okay, similarly here we are taking this metal piece as 1 kg, or we are comparing the metal piece with the weight of 1 kg of onion. Similarly is the case of atoms. Here instead of metal piece we are taking 1 by 12th a piece, this one small piece of carbon 12 atom is kept there, and we are filling the other side with any other element. Okay, so one piece of carbon 12 is kept over at one side and we are going to compare it. If you fill a hydrogen atom, then only one is needed. If it is an oxygen atom, oxygen's weight is 16 AMU. That means you need to keep 16 pieces, then only it will match with the oxygen atom. 16 pieces should be kept so that we can measure the mass of oxygen atom. So thus we are comparing it, and that is called, actually AMU is a relative mass. In relation to 1.1 by 12 AMU, we are getting this atomic mass of other elements. So what is relative atomic mass? Relative atomic mass of one atom. It is the mass of one atom in comparison, compared to 1 by 12 the mass of carbon C12 atom. Relative mass of all elements are found in respect to C12 atom. If it is said 12 AMU means what? Yeah, 12 pieces of that 1 by 12 the mass of carbon atom is needed to satisfy the weight. Okay, so 12 AMU. How will you convert this? If you want to find it out in kilograms, we have to multiply 12 into 1.66 into 10 raised to minus 27. So 12 is the weight of the carbon atom. So 12 AMU is the weight of carbon atom itself. If you want to find it in kilograms, you have to multiply with this 1.6 into 10 raised to minus 7. So all these atoms, all the weight of these atoms are written in the periodic table, and its in relation to, or by comparing it with the mass of 1 by 12th the mass of carbon atom. That is taken as a standard weight. Okay, and we are comparing it with other things. Okay, now so we have studied about all those things, and the question asked is, how does atom exist? So we have seen so many elements like hydrogen. I'll be writing symbols. So helium, iron, calcium, magnesium. How does these atoms of these elements exist in nature? Obviously, we know about acids, bases, salts, and all these things in there. On those compounds, we have seen acid, hydrochloric acid is HCl. If you take a salt, it is NaCl. It is found in a combined state with, so here sodium atom is combined with chlorine atom, or sometimes you can also see iron which stays alone, iron as iron metal. Calcium we can see as calcium, and also as some other compounds combined with some other elements such as calcium carbonate or calcium chloride. And also, what is the gas that we breathe in? It is oxygen. It contains two atoms of oxygen to give O2. Hydrogen, H2. Chlorine gas, Cl2. Okay. So, on the Earth's crust, atoms exist in the form of molecules, or elements exist in the form of compounds. Okay. So, let's read this. Atoms of most elements are not able to exist independently. As such, gold can exist independently. Silver, obviously silver can exist independently. But there are some atoms of certain other elements which cannot exist independently. These atoms form molecules and ions. They form molecules. And what are molecules? These molecules and ions aggregate in large number to form matter that we can see, feel or touch. We can't see atoms. So, but when atoms or these molecules come together, it will make a huge mass. Then we can see it, feel it or touch it. Okay, so let's see what you have all studied about atoms, its structure, all those things, and then we have come into a conclusion saying that atoms can, or most probably it is not able to exist independently, or it need to be combined with, it has to combine with other elements. Okay, so the reason for that we will be studying in the next chapter. So molecules, what are molecules? Definition for molecules. Molecules in general, a group of two or more atoms that are chemically bonded together. That means it is tightly held together by certain attractive forces, and a molecule can be defined as the smallest particle of an element or a compound that is capable of an independent existence. That means if it is a molecule of an element or a molecule, that is two or more atoms coming together, held together by an attract force, tightly held together, those kind of things, that is newly formed molecules, is capable of independent existence. First we said atoms cannot exist independently, but the molecules formed out of it can exist independently. And then molecules shows all the properties of that substance. Okay, so atoms of same elements, for example H plus H forms H2 molecule. So these are atoms of the same element forming hydrogen. Hydrogen plus hydrogen giving hydrogen molecule. Or different elements, for example hydrogen combining with chlorine to give HCl, can join together, we will get HCl molecule. can join together to become a molecule. Okay, so those were the definition of molecules. So it is said that sometimes atoms of same element combine to form what? Molecules of element. Okay, so molecule of element constituted by same type of atom. Molecules of elements are argon. Argon is an inert gas. It can exist singly. Only one is needed. It does not have to combine with any other argon atom or any other atom of another element. It can exist independently. Again, helium is also inert gas. It is made up of only one atom of that element, and those kind of atom are called monoatomic molecules. If it is made up of only one atom, that kind of molecule are called monoatomic molecule. Okay, so again, a molecule of oxygen contains two atoms of oxygen. Hence, two atom O plus O giving, it is called diatomic molecule. Sometimes three atoms of oxygen combine together form O3, or sometimes five atoms of phosphorus combine together forming, four atoms of phosphorus combine together to form P4. So this three atom triatomic, these are all Greek words for letters, numbers, and if it is 4, it is called tetraatomic. Some have got 8 or more. Okay. Yes. So these are the type of elements. Argon is a non-metal. All these are non-metals. It is a monoatomic molecule. Atomicity, we'll see. The number of atoms present in the molecule is called the atomicity of that molecule. So in the case of argon, helium, it is monoatomic. That means there is only one atom. Oxygen is diatomic. It has got two atoms. And chlorine, nitrogen, oxygen, nitrogen, chlorine, iodine, bromine are all examples of diatomic molecules. Phosphorus has got 4 atoms together. Sulfur has got 8 atoms together. So sulfur, it's called as a polyatomic molecule. There are again sometimes the atoms of about 60 carbon can be formed in different ways in carbon atoms. Sometimes 60 atoms come together to form a big molecule. Okay, so what is atomicity? So you should be very thorough about the word atomicity. There is another word coming called valency. So what is atomicity? It is clearly said that the number of atoms constituting a molecule is called atomicity. Okay, I'll tell you another one. CO, CO3. There is this atom, and this atom. How many of 3 atoms? 3 atoms of oxygen are there. And 1 atom of carbon is there. And 1 atom of calcium is there. So, total there are 5 atoms. So, we can say that this calcium carbonate atomicity is 5. So, here we are studying about elements. Molecule of elements. Next comes the molecule of compounds. What is the difference between the both? In the first case, same kind of atoms. Now here, atoms of different elements join in definite proportion. We have learned about that word, no? To form molecules. Atoms of different elements join together in definite proportion to form molecules of compounds. Here some examples are being given. Okay, we'll get more into it. Okay, so we'll discuss about this, what this definite proportion means. So who is the scientist who proposed the idea of definite proportion? Proust. He was among the scientists. Antoine Lavoisier. Lavoisier found out what are these? These are laws of chemical combination. Okay, so what are the two laws of chemical combination? Matter can neither be destroyed nor created. That was said by Antoine Lavoisier. And second law states that atoms of different elements join together in definite proportion to form molecules of compound. The example that we have learned, that the water from the ocean, water from the tap, if you take water that is prepared in the lab or which is got from the well, river or anything, it always contains two hydrogen atoms and one oxygen atom. Okay, these are molecules of atom, and we will see what ratio by mass is. So you have seen from the periodic table, mass of hydrogen is 1 AMU and oxygen is, I'll tell you, is 16 AMU. So it produces water. If you calculate, you will get as 18 AMU. Okay. So here what happens is, two hydrogen atom is there reacting with one oxygen atom. 2 is to 16 is the proportion, or if you proportion by mass, it's ratio by mass. We have taken the mass here, right? We have taken 1 AMU and 16 AMU mass, and we are writing it down and simplifying it. Simple ratio, it is 1 is to 8. Now we are taking, there is another given, ammonia. No need to worry about this chemical formulas and all. How will you? It will be gradually, you will be able to grasp it. Okay, so ammonia, there is nitrogen there and there is hydrogen. Nitrogen's weight is 14. Okay, and you know that this is 1. So in the formula there is 3 hydrogen present. So the proportion with which nitrogen and hydrogen combine in ammonia is 14 is to 3. If you take another one, carbon dioxide, from the name itself we can see that there is C and O2. Again, I'll be writing it away. Carbon atom weight is 12 AMU plus 2 atoms of oxygen is there, and it is 2 atoms of weight is 16. So ratio will be 12 is to 32. If you right? Yes, 12 is to 32. If you get a symbol ratio of it, we can divide it both by 4. We'll get 3 is to 8. So 3 is to 8 is the ratio with which in every case carbon will be combining with oxygen. If it has to produce carbon dioxide, it will combine in this simple, definite simple ratio 3 is to 8. So that was about it in this class. So we have studied what atoms are, about the symbols of the atom, then number, right? We have studied about the number of atomic number, which is equivalent to the number of protons or number of electrons of a neutral atom, and that is an identity of an atom. Then about atomic mass. Mass depends upon the mass of number of protons, mass into number of electrons that is present in the middle. And since it is very, very tiny, we cannot measure, or we cannot take this, we cannot work with one atom, okay, or we cannot use kilogram as the unit. So we use another unit, a smaller unit called AMU, atomic mass unit, to work with the atoms, okay. An atomic mass unit is actually a standard weight that we already know that what it is. It is what? It is 1 by 12 the mass of carbon 12 atom, and we are keeping that in one end and we are measuring the other one. If you keep one piece of that carbon, 1 by 12 the piece of carbon atom, it will be equal to 1 kg, 1 atom of hydrogen that we have. If we keep 2 here, 2 means helium, you will get. If you get 3 1 by 12 one, it will be lithium, will be the weight of it that we are combining or comparing. So this 1 by 12 the mass of carbon atom is known as the relative atomic mass, and we are comparing the mass of each and every element with the mass of 1 by 12 the mass of one carbon atom. And atoms can exist independently. In some case, or most of the case, it is dependent in nature. It will form molecules combined with other atoms. Molecules of elements are present, and molecules of compounds are also present. And we have studied about atomicity, and some elements are 2 atoms combined together form diatomic, 3 atoms combined together to get triatomic, and all those things. Right? Hope it is clear. So go home and learn it once more. And if you have any doubts, you can clear it. You can ask me directly. Okay? Okay then. Thank you. So see you in the next class.